Hey guys, here we are again with a video example. This one is going to be on how to find the diagonals of a box, the length of the distance from one diagonal of a box. And we're going to apply it here as if we had it in a room. So we have our situation here is a box or a room. This room is a 5-foot by 12-foot room, and it's got a standard height of 10 foot. So it's got a 5-foot width, a 12-foot length, and a height of about 10 foot. It looks like. All right, and our question here is to find the distance from one diagonal to the other. So when they say one diagonal to the other, they're just talking about from one corner of the box all the way to the opposite corner of the box. So like here we see from point A all the way to point B. So this right here, this line A to B, we don't know how long that is. That's going to be the question that we're trying to solve here. So well, for us to do that, we're going to want to break this problem down. We see we got some right triangles here. See, this is a right triangle, so we can use our Pythagorean theorem to solve the problem, but we don't have all the information we need yet. Because well, if I'm going to try and do this in the outline, if I'm going to try and solve this Pythagorean theorem triangle here, I'm going to need two of the sides, right? So if this is the right angle, then this must be my one leg, this must be the other, and this must be the hypotenuse that I'm trying to find. But the problem is, well, if I look at my A, B, and C here, I'm looking for the C. I know the A. A is 10 because it says here my height is 10. But I don't know what that B yet is because it is unknown to me. So let me just clear out my markings. I don't know this line yet. Let me highlight the line I don't know. I don't know this line here. This line from C to B. If I knew that line, I know my height is 10, well, then I could solve for my C and figure it out. But I don't know that line from B to C. So our first step is going to be to get this line here from B to C. All right? So what I'm going to do here is I'm going to go ahead and kind of draw this bottom base square, this whole square of my rectangular prism. I'm going to redraw that right here. That way we can look at it from a top-down perspective. So here we go. So here we go. I have it drawn from a top-down perspective. Now, granted on my box over there, the 12-foot was actually on this side. But I know if it's a rectangular prism, that this side's 12 foot, this side has to be 12 foot too. So I'm going to go ahead and move that 12 foot to be on the side of my triangle. And again, what I'm trying to do here is I've broken this problem down into two parts. I'm going to first find this unknown length here between B and C. And once I have that, then I can use that along with my height of 10 to find this unknown angle out. But for now, I'm going to do my step one, which is to find this line CB, which is right here, line C to B. For me to do that, I know I can use my Pythagorean theorem because this is a right triangle. This is a right triangle, so I know that A squared plus B squared is going to equal C squared. So let's go ahead and do the math here. If A squared plus B squared equals C squared, I know one leg here would be 12 foot and the other leg would be 5. So I'm going to plug those in. I get 5 squared plus 12 squared equals C squared. All right. So I'm going to go ahead and just expand that out. I know 5 squared is 25 and 12 squared is 144. Now I'm going to group my like terms. 25 plus 144 is 169. And now I'm going to get C by itself. So I'm just going to take the square root of both sides. If I take the square root of both sides, well, the squared will come off of a C. And the square root of 169, well, that's going to be 13. So that lets me know that that length of a line between C and B right here, that distance must be 13 feet. Now that I have that number, I have one of the two legs I need for my other right triangle. So what I'm going to do is, go ahead and just write that here. I got my 13 foot here. I'm going to go ahead and delete this rectangle, and I'm going to go ahead and draw the new triangle, this one here, from a side perspective as well. That way I can add in my new lengths of 13 feet for my width. And I'll put a 10 in there for my height, right? All right, so let's see it. I'm going to put those values in. Again, I've redrawn my new triangle here. this triangle ACB. I've drawn it right here. And I've done that way I can use my Pythagorean theorem again. I'm just going to plug the values in. Again, I have a leg of 10 for A. I have a leg of 13 for B. I'm going to plug those values in. I'm going to solve it for my unknown leg C, my hypotenuse. So here we go. All right, let's plug those values into our A squared plus B squared equals C squared formula. I get 10 squared plus 13 squared equals C squared. I'm going to evaluate that out. I know 10 squared is 10 times 10 will be 100. 13 squared is 169. So I get 100 plus 169 equals C squared, which is 269 equals C squared. Take the square root of both sides to get our final answer. Now, this is not going to be a perfect square. I used a calculator, and I got C as approximately 16.4. So it is important that you use that approximate symbol there because it's not exactly 16.4. It's not a perfect square, so it's some number that's going to go on forever. But we did end up finding that it's approximately 16.4 feet. And again, that is the distance from A to B, 16.4 feet. And that's about as hard as it gets for the Pythagorean theorem, people. All right, guys, I hope this helped you out. I hope you understood it. If you have any questions, show up during after school help. I'm more than happy to help.